Welcome back everybody to my channel and a deep dive into HashSets. Okay, so now that we understand that we have an array list that's contiguous and then a linked list that's fragmented in terms of memory, now we can talk about a hash set. Okay, now in Java, a hash set doesn't exactly use the data structures that I'm going to talk about in this lecture, but they used to. Okay, now they use something called the red-black tree, which is it's going to be the same approach. Okay, .NET actually uses the array hash function linked list method, and Java uses the red-black tree. But okay, we're going to talk just so we can understand how a hash set works. We're going to look at it in terms of having an array and a hash function and a linked list. So that's actually three things that I want to mention here, because that's really all you need to understand. Okay, and then I can talk about the O of n, O of 1n, and time complexity, and so forth. But now you have this third data structure, which is a hash set. Okay, it could be HashMap, hash table, which is going to use a combination of both. It's going to use a combination of a contiguous memory pattern and a combination of a fragmented memory pattern. Okay, so what we need to understand here is we first need to understand, okay, we're going to be using something called just a typical array. Okay, and that's why I gave you the array list example. That's what it's going to use. So the hash is going to use an array. It's also going to use, in between, it's going to use a hash function. Okay, and it's not as complex as it sounds. Okay, when you talk about hash functions, okay, you start thinking, oh, I'm so smart, it's mathematical. It's not a big deal. Okay, yes, you have to come up with a hash function, absolutely. Okay, but it doesn't have to be something where you're trying to crack a NSA encrypted code. Okay, a hash function could be anything. You can create a hash set. Okay, anybody can create a hash set. And obviously, it does have to do a little bit of how efficient your hash function is. But again, we're trying to understand the hash set. We're not trying to build our own. Okay, and then third is your linked list. Okay, linked list. So how does it visually look? Okay, so if I'm building a hash set, and this is why it's so efficient, okay, what's going to happen with a hash set is you're going to have a distribution of buckets, okay? And this distribution of buckets is really going to maybe made up of an array. So you can think of it visually as you have a bucket here, okay? Then you have a bucket here. Then you have a bucket here. Then you have a bucket here. And it all depends on how big your original hash set you made it with the original size. Okay, so you can think of the size, okay, initially as a contiguous memory structure. Okay, great. But now what happens? Okay, so if I add an element to a hash set, what's going to happen is this element is going to go through this hash function. Okay, so let's say, and again, just I'm being very simple here. What's going on here? Let's take this out. Okay, let's say we have, let's say we want to insert the number 5. Okay, now how does 5 get into this hash set? Well, what happens is this 5 is going to get fed into this blank box, which we're going to call h of x, which can be defined as your hash function. Okay, and based on this hash function, it's going to land on one of these buckets. Okay. Now, how does it know, right? How does it know that it needs to land in one of the buckets? Well, that's why you, if you were creating this hash function, you're going to indicate with your hash function how we can land on these buckets. And if it doesn't land on these buckets, it's not the end of the world. You can have a default that says, okay, if it doesn't land in these buckets, we'll have a default bucket, which is 0. Okay, so that's one approach. Okay, but let's just say we made a pretty decent hash function where every time we feed it, it's going to end up in one of these buckets. Great. So if I hash 5, okay, I feed it into my hash function. Okay, let's say it ends up in bucket 0. Great. So we're going to put it in bucket 0. Excellent. So we'll have 5 over here. Okay. So every element when you call an add, okay, is going to be hashed into one of these bucket keys. Okay, and that's why you have a key value relationship here. Okay. Now let's say I want to I want to add another element, right? Great. So if I add, let's say I want to add the integer 100. Okay. So if I add the integer 100, I have to go through the hash function again. And let's say this time it actually doesn't hash to 0. It actually hashes to 2. Okay, so this will hash to 2. And it goes into this bucket here. Perfect. Okay. So now we're getting to the gist of how this whole thing is working. Okay. Now I'm going to show you a situation where there's a clash or a collision, and this is called chaining. Okay. So most hash sets use this chaining method so that if you do have a collision, it can chain along elements within a bucket. Okay, so let's say on the next element, we want to insert, sorry, this was 100, right? We want to insert 8. Okay, let's say that actually hashes to 0. So what's going to happen there? Well, what's actually going to happen is because, and remember I said, you know, I've talked about this. I've talked about this, but I have yet to talk about this, right? And I'm going to start talking about it now. What's going to happen is we're going to actually form a linked list, okay, within each bucket, okay? And here's another problem about HashSets. And that's not a problem, but it's something that you should be aware of. It's never ordered. Okay, so don't expect to add items to a hash set and have it come out organized or ordered or sorted. Okay, there's data structures for that. You can have an ordered hash set. Again, we won't talk about that here, but it's not going to be ordered. Okay, so let's say this hashes into 0. Okay, so that means that now, okay, this part to the right is actually a whole bunch of no linked lists. So we can have something like that. Okay. And then if let's say I want to add an additional element, let's say we do 2, and then that hashes to the second bucket, right? So what we'll have is we'll have something that looks like this, where remember that this side here, right? Everything to the right, everything in this red block, okay? Every item in a bucket is going to be a list, a linked list, okay? Where we don't care where it's inserted in RAM, because we don't want to go with the approach of having a array list and we have to contiguously allocate memory. We already did that. We already did that initially, right, with the buckets. And that at least that makes the most sense in terms of speed, because once you have your buckets set up, then hashing itself is a very quick process. Because as you add elements to the linked list, right? If I add another element here, do a -3, right? When we add elements to this linked list for this bucket, we're just going to add it. We're not going to allocate anything, or we're not going to look. Remember, it's kind of like a car in a parking lot. So you're trying to park a little Tesla here, right? So you're parking a Tesla, and whatever open spot you find, that's where you're going to insert it. Same thing here. Same thing here, right? We're going to park little cars as we go through. Now, the complexities of these, okay, so let's talk about that a bit. So for everything in terms of, we usually with time complexity, it's best case, worst case, okay? So for the worst case, for inserts, okay, so we can say that for inserts, the worst case is O of n. The worst case for a search is O of n. Okay, and then for a delete is also O of n. Okay, an insert can be O of n because if it hashes to the last element in your array, right, that's n, right, and then I need to insert it to the end, right, so that's also going to be O of n, right. Same thing with a delete. If I want to delete an element, I have to go through, the worst case is I would have to go through the last one and then insert in the end. The other case that you're seeing here is that we could have a situation where everything buckets into just one bucket, right? So if that's the case, then you get into these situations here, right? Where if, let's say, we had all these elements in O of n, so we'll do something like this here. We had like 1,000 elements or even 1,000,000 elements on the 0th bucket. Then you're getting into that situation where everything is colliding into 0. So anytime I need to search for something, I have to go to bucket 0 and then do just a sequential search, right? So that would be O of n. But the average case, it just happens to be for all these, okay, for insert, search, and delete, the average case is actually O of 1. Okay, which is really good. Okay, even the insert, search, delete worst case O of n is pretty good. I would kill for an O of n algorithm for any problem I solve. Okay. So it's very, very well designed. It's very, very well designed. Okay. Now, should you be using HashSets for everything? No, you shouldn't. Of course not. Okay. Of course not. You don't want to overcomplicate your code because, again, you have a combination of data structures within a hash set. Okay. So anytime that you want to do a really quick search, okay, you're better off going with a hash set, because the hash set is going to give you the fastest search just because of this hash function. Okay, just because of this hash function. You can't loop through a hash set because of the hash function as well. Okay, so you have to go through, that's why you have a key value pair. Okay, but again, Java takes care of that for you. Okay, or any high level language takes care of that for you. Okay. So I think this is enough to give you a high level of how a hash set works. Hopefully I didn't confuse you too much, and I'm trying to make it as simple as I can. But yeah, please reach out or put any comments if you see something that I made a mistake on. Please let me know. Happy coding.